Hey, grade 10. Welcome to this last mini lesson on ionic compounds. It's going to be a three-part, so three very mini lessons in here that's going to bring you from page 22 to 27 in your note packets and will lead us into naming acids, okay? So it's a last few little ripples to the naming and balancing of ionic compounds. So basically what a Ternary ionic compound is, this is directly in your note packet, page 22 here. So what that is okay, I'm on the right one here. It's when you're naming a normal ionic compound, so but it contains a polyatomic ion in there. Okay, so you see that term polyatomic ion, you don't know what that is. I'm going to explain that momentarily. So the example that we're talking about is right here, magnesium chlorite, okay, is what this is called. But you know, because that you see the ClO, we have a capital C, lowercase l, and then capital O here. You know, that's two separate elements, okay? So what a polyatomic ion or a Ternary ionic compound is, it's something that really, it has three different types of atoms in it, okay? So we have magnesium, we have chlorine, and we have oxygen, okay? So what are we going to do to name it? We can't use the same rules, okay, because there's more than two parts, just like we talked about with ionic compounds. So we need to use our periodic table because these have very specific, naming rules, okay? Okay, so what we're going to do is we're going to go to our periodic table. Okay, right here. Okay, and this chart right here, is your table of polyatomic ions. Okay, so you look in here. In the other one, it was ClO2. It did have the number 2 on there if you look at your note packet. So we find that it's chlorite. And we don't have to change anything. That's just the name we're going to use, okay? And it's right here, okay? So that's the name we're going to use. Sec here, trying to erase these marks for you, okay? And then we go back and we can write in our answer as magnesium chlorite. Okay, oh, shoot. Okay, so that's what it's going to be. So you have a few pages here. I know it seems like this video is going to cover a lot of pages, but there's 2 pages here of just practice with that. Feel free to use them all if you wish, and feel free to just do the first page if you're confident, okay? The second little part of this mini lesson here is hydrated compounds. So also ionic compounds could attach themselves to water molecules, basically is what's happening. And you'll see here the example that they're giving right here. It's the same one. So it's magnesium sulfate heptahydrate is what the name of this is. Basically use the same rules to name the first part of it as your ionic compounds. So that becomes magnesium sulfate. Okay, then you use this chart here and identify it. So this was 7H2O. 7H2O. Okay, so you look at 7 on the chart, and you put hepta in front of it, and then the word hydrate. You don't write water, it's called a hydrate, okay? So that's how you come up with this name. Okay, if you remove, funny thing about this one, it's got a little, here, if you take the water out of this magnesium sulfate, it's actually what you use to absorb water. A lot of, mechanical shops will use it, and maybe even on your sidewalk, okay, to get rid of some water there, or even ice. So you can remove the water, and it will desperately try to absorb that water back to become complete, and that's how it absorbs water, okay, at a very elemental level, okay? Oh. Last but not least, we're going to get into, well, there's more practice there. Last but not least for this little lesson is we're talking about solubility of ionic compounds. And basically all this is learning how to read a part of your chart. So what you're going to look at is you're going to first look for your anion in a chart, and then you're going to across the top of a chart, and then you're going to look down for the other part of it. So the anion here, you're going to look for the cation below here. So once you go into your chart, okay, having a hard time here. It's on page 10 of your data booklet, so it's just below your thing here, right here. Okay, so you're going to look for the second part of your equation in this top part right here. Okay, you're going to look for your second part of your equation right here. Okay, so once you find your second part, so let's use the first example. The first example, just wait, I got to flip my note packet here so I don't have to keep going back in. Below is AgNO3. NO3. Okay, that's the example in your first one. Okay, so you look for it, and then you're going to fill out your chart. So it's asking you what's a state as a pure substance. Is it a solid, liquid, or gas? What's its solubility, and what's its state in water? So to look this up, the state of pure substance at solid, liquid, or gas, you use the normal periodic table, and you look at your color coordinated there. Whether it's gray, white, or black. So that's the same way we've already practiced that, so I'm not going to talk about that right now. But the solubility comes in here. So I'm going to look for NO3 along the top. Here is NO3. Okay, and then I'm going to look down for the first part. So the first part is the Ag. Okay, I look down. Ag's in here, but it says part of a larger compound. It's not alone, so it doesn't fit here. So I don't see the Ag there, so that's going to fit in the other box, which is most. That means it's got high solubility, or it's very soluble, or it's high, so I'm going to put an H in the third column of that chart. Okay, and then its state in water is written right here. It's AQ, that means it's aqueous, okay, means it's water-based, okay, going forward, okay, so that's what you fill it in. The next one is NH4OH, okay, so I'm just going to undo here. Okay, the next one is, so we're going to look for the OH portion. Here it is right here. Okay, I'm going to look down the thing for NH4. Here it is. So again, it's going to be high solubility, and it's going to be aqueous. The third one's a little different. There's actually a typo there. It says S. It should say SO4, so it should be written SO4 as the second part of number 3. So where is SO4? Right here. Okay. I'll find SO4, then I'm going to look for the other part, which is PB. Where is it? Where is it? There it is right there. Okay. So it becomes low solubility, and it's going to be solid. Okay. Please note, so it's very important to look at the numbers that are down low, but not necessarily the little numbers up high, because the numbers up high refer to its charge. Okay, and the numbers down low refer to number of oxygen molecules that are there. So this would, for CO3, it would be 1 carbon, 3 oxygen molecules, and it has a charge of -2. Okay, so it's important, we got to look for the little numbers that are lower, okay, on the lower side, but not up high. Okay, so that is how to name polyatomic ions and ionic compounds from start to finish. You should be ready to get up to page 27 of your notes here. And we'll move into naming acids next time. Thanks so much, guys.